Okay, I'm calling this class Practical Lessons from VRF Systems because the lessons we're going to learn are extremely important when it comes to VRF, but should be applied across almost every aspect of installing refrigeration systems, especially larger commercial refrigeration systems. So, even though these are commissioning steps for VRF, you should take this and run with it when it comes to installing refrigeration systems. The more you can apply these principles on every system you install, the better a technician you will be. Um, it was a big step up for me personally after, the first VRF class I took probably 10 or 12 years ago, something like that. Um, it was a big step up on how I started installing systems when I started to apply these principles on residential systems and mini split systems and pretty much every system I install. So as we go through this, keep this in mind. Keep that in mind. Don't don't walk away from this class thinking, okay, I have to be this careful when I install a VRF system. Think about it as I have to be this careful on every system that I install or service because it'll take you that next level up as um, you proceed in the trade. So most of this stuff is refrigeration side oriented, but that's like I said, there's other little tidbits that you'll gain here and there as we go through everything. So we're just going to read through some of these commissioning steps for now, just to make sure I touch on everything, and then as we proceed, we'll talk about other aspects of these particular items. So for now, make sure compressor shipping brackets removed. Make sure shipping brackets are removed, right? Always double check that. I even get bit sometimes on especially smaller package systems. It can be something you can forget to double check. So try and remember that. Stop valves are closed and the system's been pressure tested. Make sure you pressure test your system. In the case of VRF, we're usually talking 550 or 450 psi. 450 psi is pretty common across R410A systems in general. So I try and always hit that 450 psi mark when I'm testing, unless there's some other mitigating factor or I know the equipment manufacturer doesn't recommend that test pressure. But the lesson there is always test at the highest pressure that you are allowed to test at based on manufacturer's instructions. And for 24 hours minimum, any time that you have the time available on a job, you're doing an install where you really don't have to be done today, you can come back tomorrow or after the weekend. Leave the system on pressure test as long as absolutely possible. A lot of times it'll just give you extra peace of mind because that 1 hour or 2 hour pressure test generally isn't enough to catch a smaller leak. But if you leave it on over the weekend, you'll either A, know for sure that there is a leak, or B, know for sure that there aren't any leaks because over the course of a weekend it didn't drop at all or it only dropped in relation to temperature, and we're going to talk about that more later. But leave a pressure test on as long as possible. If you can get the piping done, when you're doing an install, work towards getting the piping done first and throw the pressure on and leave it on as long as you can until you have to you have to start your vacuum. Leaving your vacuum on and your pressure test on as long as possible is always recommended, right? Triple evacuate to 500 microns or less. And we're going to talk deep about evacuation. So I'm just going to gloss over that for now. All liquid lines are measured. I always weigh in by charge if possible. You can charge by subcooling and superheat all day long if you want. But if you just know the approximate length as close as possible of the liquid line and just weigh in your additional charge, I almost never have to adjust my charge after I've weighed it in. Um, just weigh in your charge. It's way easier. It is way easier to weigh in your charge than to charge it by subcooling. Weigh it in, then double check it based on subcooling or superheat. But I personally, my philosophy has always been just weigh it in. Just how long is the liquid line? About 40 feet. Weigh in about an extra 40 feet worth of liquid line. charge. What is it? I always have to look it up, but I'll look it up and we'll double check at some point how much charge you weigh in based on your liquid line, or we'll discuss it when we go over refrigerant piping or something like that. But whatever the manufacturer says is your extra charge per foot of liquid line. Just weigh it in based on that. Pull up the manufacturer's chart or pull up a guide that tells you how many ounces to weigh in per foot of line, and do that instead of trying to charge by subcooling and superheat all the time. It's way simpler, it's way faster, and you only have to double check your charge when you're done. You know it'll be right. Especially when it comes to microchannel coils and things like that. You need to be weighing in the charge anyway on those. You need to be weighing it in on VRF anyway. You need to be weighing it in on mini splits and things like that anyway. So why not just do it with every system, because it's that much easier. And then if you got a weird issue with subcooling or superheat, it's probably not the charge. It's probably a different problem that you need to evaluate. You've eliminated that possibility at the get-go. Much better practice, if you ask me. Much better practice to always weigh a charge in. The stop valves are open if third-party shutoff valves are used. That's specific to VRF. VRF, sometimes you'll add extra valves to make servicing simpler on the system. You want to make sure those extra valves are open. But one thing to keep in mind is a lot of our communicating systems, either the system had to have been powered before you start vacuum, or it can't be powered before you start vacuum, and complete vacuum for that matter. So double check if there's any requirements like that in your particular system, especially if it's some type of communicating system, whether it be a very high efficiency system, a VRF, a mini split, something like that. Anything that has an electronic expansion valve, sometimes there's particular steps you need to take before you start a pressure test or a vacuum. Make sure you double check those requirements with the manufacturer's instructions. All your remote controllers are installed and correctly wired. Thermostats installed correctly wired, things like that. Always double check you've got all your wiring in good. All your condensate drain piping is connected, including fan coil tie-in, and insulated as required. Refrigerant lines are completely insulated, including flare nut connections. All ductwork is connected and air filters installed. Line voltage is checked and verified. That's a big one. Double check, double check your line voltage is right, right? Um, w- especially if you're dealing with commercial, you might have got shipped the wrong unit. You needed 463 phase and they shipped you 233 phase or something like that. Um, double check that. Double check that your system has the right voltage and you're feeding the right voltage to the system. Because the last thing you ever want is to damage parts by having the wrong voltage. I've seen people do it on mini splits. Connect 240 when it's a 120 mini split or something like that. They don't realize it, and the next thing you know, you got bad circuit boards and stuff. It's one of the last things you remember to check sometimes, but it's one of the first things you should check is that your line voltage is correct, because it affects everything else. This is just their guide on removing the shipping brackets. We'll skip that. Pressure test connections, heat pump, and heat recovery. So, connect up your manifold gauges, connect your nitrogen cylinder. Don't energize the units when it comes to VRF, but like I said, always double check everything else if there's requirements, and follow the pressure test procedure. So we're going to get to the pressure test procedure. So a system nitrogen pressure test. 3-step system pressure test. This is a great way to pressure test refrigerant systems. All right. In general, it's a good way to do it. Start at 150 psi. Start between 50 and 100 psi and see what happens. If you got a leak at that low of a pressure, then you need to fix it. All right. It's going to be pretty easy to spot most of the time. You need to hunt it down and fix it before you start adding extra pressure. Just jumping straight up to 450 or 550 psi, you're going to waste a lot of nitrogen if you do have a leak, and it just in general makes it a little bit more difficult. So just start at 150, see what happens. If you got a leak, find it, hunt it down, fix it, take it back to 150, make sure it holds for, at least a few minutes, if not an hour or two. If you're doing a 24-hour pressure test and you've got time, start at a low pressure, make sure you don't have any leak. Find the leaks you can at that point. In this case, they're saying 3 minutes. Start at 150 psi for 3 minutes. 325 psi, jump it up the next level. Hold that for a few minutes. 5 minutes is what they're recommending in this case. But take it up to about halfway your test pressure and make sure that it's still holding. Okay, still holding. Take it up to full system test pressure, whatever that is. In this case, 450 or 550 psi, and hold that for 24 hours. Again, it is ideal that you hold your pressure test for at least 24 hours to ensure that you don't have any leak. It's a nice long amount of time. I even with VRF, I don't even do 24 hours. I do at least a weekend. At the minimum, put it on Friday, check it on Monday. Um, Most of the time, I end up leaving it on for a week. There's still plenty of stuff you have to do after you install your refrigerant piping. There's a lot of wiring and things like that to button up. You're rarely in a rush when you're doing a VRF system. Leave it on for a week. Make sure there's nothing, because this is, again, the most important thing about VRF in particular, but every system, is you want a factory quality system. You want to make sure there are no leaks. We don't have the luxury of having helium or hydrogen. Well, no, yeah, helium or any other extremely light gas with a bunch of sensors to make sure there's no leaks in the system. We don't have those luxuries. So the only thing we can use to help emulate that is time. So the amount of time that we allow it to sit helps ensure that there's not going to be any leaks. Charge it with nitrogen, leave it on as long as you can. Make sure the pressure doesn't change, and if it does, then make sure that the fluctuations correlate with temperature. And this is the next part. Um, you'll hear it a lot, and it's not true. You'll hear it a lot that nitrogen does not change pressure with temperature. That's impossible. Every gas changes pressure with temperature. So when it comes to nitrogen, it tends to change less over time than a mixture of air, and, which is what less than air, which is a mixture of nitrogen, oxygen, and water vapor and carbon dioxide. So it will change less than that mixture of gases, but it will still change. So, nitrogen pressure test is subject to fluctuations, period, but above 300 psi, it starts to become really noticeable. So, on low test pressures, because nitrogen doesn't change very much, it's going to be harder for you to see that change. But once you start getting above 300 psi, because um, because we're dealing with a higher pressure, the percent change starts to become noticeable, right? Use this formula to compensate for temperature drop or rise from one day to the next when performing a 24-hour pressure test. And here's the formula they give you. And this is basically just a simplified version of doing an actual gas law formula. So I would highly recommend that you take this, write it down, try and remember it. It's a pretty easy formula to use, and you don't have to go through the whole P1 divided by P2 equals T1 divided by T2 or whatever. Boyle's gas law. You can just use this when it comes to nitrogen, and it'll get you right where you need to be as far as the pressure change from temperature. And it's basically just your temperature delta, right? Your temperature difference when the system is pressurized. Subtract the temperature when the pressure is checked. Multiply by a factor of 0.8 to get the pressure drop. So if it was 100 degrees outside when you put the pressure test on, and then it was, so make sure the calculator is up here. Yeah. So if it was 100 degrees, right? And then it was 80 degrees after the weekend you got there, is 20 degrees difference, right? So basically your delta T times 0.8 is 16. You'd have a 16 psi difference over that weekend. So it's noticeable, right? It can get noticeable. So that's the way Daikin recommends doing it. I've also done it based on the actual gas law formula, but this gets you where you need to be. Okay, so that's one way to double check. So don't freak out, if you drop 5 or 10 psi until if there's a difference. And pro tip on this is, remember too, you're dealing with the average temperature. So if most of your piping is in a building that's conditioned, that that shouldn't change as much as if it's all outside in unconditioned space, right? So if only 10 feet of your piping is on the roof where the temperature difference occurred, and inside it stayed the same temperature the whole time, remember that pressure is going to equalize, and most of that pressure should have stayed the same because there really was no temperature difference that the most of the piping interacted with. So you get a 20 psi difference over a weekend when there's a 10-degree temperature change, and but inside the temperature stayed 70 degrees pretty much the whole time, and you probably still have a small leak, right? But yeah, just keep that in mind, I guess. um Evacuation. Oh, yeah, before we get to evacuation, because we want to get deep into evacuation, let me double check a few things here. Um, yeah, before we get into evacuation, because that's probably going to be the longest topic in this class. The next thing I want to talk about that I don't really have any slides to show you on, but I want to talk about is purging while brazing. So there's a couple things here, right? Um, I forgot to pull this up. You know what? Give me just a second. I'll do it like this. Print. Paste in a picture here. All right. Purging while brazing. Purging while brazing is extremely important. In small systems, if you're just doing a couple joints, fine. It's not the biggest deal in the world. Don't tell anybody I said that. But if you're just doing a couple joints on a residential system, I'm not gonna jump up and down if you didn't purge while you brazed. Okay. Doesn't mean you shouldn't do it. Doesn't mean I don't do it the majority of the time. It just means that I haven't. I'm not convinced that a little bit of oxidation in there is the end of the world. That you should always purge while you're brazing, though. I'm just saying, if you end up in that situation, especially if you're adding nitrogen or something like that, then maybe don't freak out. Okay. Um, but on larger systems, or if you've got to do multiple joints or something like that, it becomes more and more and more important, right? It just increases in importance as the more joints you have to do in a system. So this has came out in the last couple years. This particular brazing regulator has come out in the last couple years, and I used it on the last VRF system, and I'm convinced that this type of test regulator is the is what should be on every truck, period. This is the type of regulator you should use. Throw the other ones out the window. Nobody's paying me to say this. It's just it's way better. Okay. So these regulators, these newer ones that they've been putting out there, and there's a couple different companies. This is just one company. Airco's been carrying them. I know. I think Johnstone. Whoever your local supply house should be able to get their hands on one. If not, you can go online and pick one up. They've got, I think, 450, 500, and 550 psi models or something like that. You don't really need to set your regulator much anyway, right? Because you almost always have your gauges connected. So where you set a nitrogen regulator is basically immaterial. It doesn't really matter that you can dial it in between 150 and 500 psi on a nitrogen regulator. It's really a stupid thing to be able to do on a nitrogen regulator for most of our purposes, right? It comes in handy for a couple things, like if you use them to blow out condensate drains or something. But other than that, it's a useless feature. It's just a byproduct of how most gas regulators are, because with acetylene, oxygen, or whatever else, you need to be able to do that. But with nitrogen, most of the time you don't. What you really just need to be able to do is pressurize the system to a high test pressure, purge the system, and set for brazing. And the real nice thing about this is your other option is your standard nitrogen regulator, your standard old school nitrogen regulator, and a little purge cylinder. So a purging nitrogen purging. Let me see if I can find one real quick and put a picture up there for those you guys have maybe never seen it, but you should hopefully have seen one before. The little tubes, right, that you hook on the side of nitrogen purging flow meter. That's what I'm thinking. So it's a little flow meter that you'll hook up to a nitrogen regulator, and it's got a little ball that floats in it, and that regulates how much your that lets you set the cubic feet per hour basically of nitrogen that's going through the system. And they're okay. They're okay, I guess. But the problem is most of them have a maximum pressure of uh what is it? They have a maximum pressure of 50 psi, okay? So there's a little thing on the side that if it exceeds 50 psi, the damn thing um the thing will blow a safety relief basically, right? So you blow that little safety relief on it, and now you're stuck. Here you go, right here, right? There's a little safety relief right here, okay? And if um if you exceed 50 psi going into it, if somebody forgets to adjust the nitrogen regulator down, then it blows that safety relief off, and you're basically screwed. You got to buy a new thing, and half the time you can't get a new safety relief. So you end up having to buy a whole new little flow meter to do your brazing, and that sucks. Okay. The other thing is you got to adjust that little ball, and most of the time you can't get down to really low flow rates, even with this. You're usually dealing with 20 or 30 CFH, which is, fine, but you actually don't need that much. Okay. So this is the old school way of doing it. And, um, your other option is set your nitrogen regulator as small as you can, and make sure you can only feel it on the back of your hand. And that sucks. So this was my other way of doing it for many years, but that sucks compared to this. All right. Compared to this thing where you set it to test, which just basically takes it up to 500 psi. You set it to purge, which puts out 30 CFH or so. So it puts out about 30 CFH, cubic feet per hour of nitrogen, to purge all the um, gas out of the pipe, purge all the air out of the pipe. And then it's got a braze setting that's just 2 or 3 CFH, an extremely small flow of nitrogen. And what that does is all you have to do is keep the air from getting back in the pipe. You purge the air out, and then you keep it from getting back in. And it only takes 2 or 3 CFH to do that. So why use more gas than you have to purge? Now, since it is such a small flow, especially on a big VRF system, you have to make sure that you cap all the ends, tape off all the ends or something that you're not purging through, so that you're purging through the line that you need to purge. Otherwise, you want to put a higher CFH through and make sure that all of the pipe is staying purged. So it does add that other wrinkle on a large system, but especially if you're talking smaller commercial residential systems, 99% of what you do day to day in HVAC and refrigeration, then you just hook this thing up, set it to purge it for about 5 minutes is what I like to do. That's probably still overkill, but I usually purge it for 3 to 5 minutes, and then set it to braze, and then leave it running the whole time until I'm done brazing, and only turn it off if I'm gonna take a long break, and then purge it again for 3 to 5 minutes, and then set it to braze and just leave it on braze while I'm brazing. And then when you're done, just set it to test, go up to your test pressure, and you're done. So there's my quick diatribe on making sure that making sure you purge while you braise. Um, Next big thing that we need to talk about that I honestly don't know where to go. There's a couple more things. Well, the other one I have a slide, but another thing I don't have any slides set up for, but I want to talk about real quick is um, flare joints. All right, VRF and mini splits have a ton of flare joints in them, and you'll get a lot of recommendations when it comes to flare joints. Here's my quick 2 cents on flare joints in general, something I think will help you, and you go where you want with it. There's plenty of guides on flaring out there. Ever since mini splits came out, everybody's an expert on flaring for the most part. But in case you're not, or in case I have a couple tips you don't. Here's my approach to flaring. Um, Try and use some flare torque wrenches at least once, because it helps you get a feel. The amount, or at least look at some torque specs for flaring. And if you've never used a torque wrench, kind of get a feel for a little bit of what it takes to get to 10 foot pounds and what it takes to get to 20 foot pounds and what it takes to get to 30 foot pounds or whatever it is. Um, get a feel for the difference of how tight that is. That's always a good start when it comes to torquing down anything. You know, we always joke about it. Hopefully, you're not one of those guys. There's no reason to just crank something down. I'm one of those guys. Nothing irritates me more if I can't get some gas pipe apart with the largest pair of channel locks. Okay, I shouldn't have to pull out a pipe wrench to take 3/4 residential gas pipe apart. It doesn't need to be that tight. You're more likely to crack a fitting or damage something than make sure you don't have leaks tightening something down that much. Just make sure it's tight enough you don't have a leak. When it comes to flares, that's extremely important because you will damage the flare if you over tighten it, especially the smaller ones, the 1/4 inch, the 5/16, the 3/8 lines. They don't need to be cranked down. Your hoses to your manifold don't need to be cranked down. So, rule number one is get a feel for what different tightnesses are, what a certain amount of torque kind of feels like. If you're reading something that calls for, you know, 20 foot pounds, what's that feel like to you? Rule number two is don't over tighten it. Okay, so my approach, I don't carry mini split torque wrenches around. It would be nice, but I don't bother. It's not, the most important tool in the box to me because I have pretty good luck with just feeling it. But the major thing that I do is I don't over tighten it. If anything, if it's a little loose, you can always tighten it up a little bit. If it's too tight, and you mess up the flare, you're screwed. You got to do it again. So just don't tighten it up too much. Tighten it till it's nice and snug. Test for leaks. And if you got a leak, go a little bit more. If it's still leaking, go a little bit more. If it's still leaking, go a little bit more. And if you get to the point where it won't stop, then you know you got to take it apart and redo it anyway. But at least you gave yourself that room to just try and tighten it up enough that it just stopped. The other thing is Nylog. Flare joints need Nylog. If you don't know what Nylog is, just look up. They got it at every supply house. Look up Nylog. Okay? Nylog. That's how you spell it. All right? Buy it. Read the instructions. You put a little bit on the face of the flare and a little bit on the threads to lubricate it. Just put that little bit on. Tighten it up. Works great. All right. It's up to you. A lot of manufacturers say you can't do that. Just put a little bit of refrigerant oil on there or whatever. Nylog works great. Ever since I started using Nylog for flares, I have leaks almost never. Okay. We went through a spat there where it seemed like every other flare joint would leak because there's always different guys doing it. We were doing big jobs. You're going back and double checking flares all the time. Um, y- Ever since I started with Nylog, using that on my flare joints, starting off a little under tightened, if anything, I haven't had to go back on a mini split that had a leak or a VRF system that had a leak or anything like that. haven't had to deal with it, and that is amazing. I love flare joints now that I use nylon. I would honestly, residential systems, I would love if they just made the joint connections flare. Screw trying to braze near that service valve. Give me a flare joint. I'll flare it, put it on, won't leak. I can take it apart later if I got to work on it. I don't have to worry about purging while I'm putting it together. That is just miracle to me. It's great. I would take a flare over almost any other connection as long as I can get to that joint later. If it's going to be concealed behind a wall, it needs to be brazed. But if it's going to be accessible and I can get to it, it should probably be a flare. That's my opinion. Honestly, I would love it if everybody just used flare liquid line dryers and flared sight glasses on everything, because it's easy to change them out if you need a new one, and you know people won't be as reluctant to do it because it's way less work. It's just, to me, as long as you start off with less torque than what you think is probably necessary, and you put a little bit of lubricant like Nylog on it, you really shouldn't have many flare joint leaks. Guys running around with torque wrenches, it's good practice. Don't get me wrong. It's great practice, but I don't think it's necessary. I just don't think it's necessary. Once you get a feel for how a flare joint's supposed to be, I don't think you really need a torque wrench on it. Will it help? Yeah. Don't get me wrong. I've done flanges on 8-inch pipe, running water mains and stuff. And using a torque wrench on a flange gasket will make sure you don't have a leak. If you need to make sure you don't have a leak, if you need to make sure, even on a VRF system, you should be making sure you don't have a leak, and a torque wrench will help you achieve that. But if you do a few, you should get a feel for where it needs to be. And I know that's an experience thing, but like I said, it would help if you used the torque wrench a little bit to kind of get a feel for what kind of torques we're talking about. Because a 1/4 inch flare, I think the torque spec is like 8 or 12 foot-pounds or something. It's way less than you would think. The smaller the piping is, the less tight it has to be to not leak, because um, it's the smaller it is, the more PSI you have, because everything's by square inch, right? So the pounds per square inch of force on something that is not very tight is greater on a smaller pipe, if that makes sense. And it's just a fact. So the smaller that piping is, the less it needs to feel really tight as you're tightening it up. All right. Hopefully that's enough. Hopefully that makes sense. But that's where I feel on that. I could put it a little bit more eloquently, but for the most part, that's the gist of how I feel about that. Um, what else? We're gonna get into vacuuming shortly. We talked about charging. Okay, so here you go. This is pretty universal. There's 0.04 pounds per foot. I forget what that is. What's 0.04? Let's pull our calculator. So 0.04, 16 ounces in a pound, right? Yes. 0.04 times 16 is, yeah, 0.6 ounces per foot. So that's your 0.6 ounces per foot, if you're weighing in a charge, is your 3/8 liquid line. That's the most common one we do, right? So they say 0.04 pounds. These numbers right here, take a snapshot, all right? These numbers are pretty much universal. This is how much charge you add based on the size of your liquid line for every system out there. I've never seen these numbers really change. Doesn't mean they might not for a particular system, but as far as I know, these numbers always stay the same. So if you got to weigh in a charge, your liquid line size by how many feet, that's how much you add. So again, I just converted pounds to ounces by multiplying times 16. So if you got a 1/2 inch liquid line and you need to know how much to add, you got a 1/2 inch liquid line, 0.081 times 16 is 1.29 ounces per foot. And if you have, 50 feet of 1/2 inch liquid line, All right, that's 65 ounces, and you can go back and divide that by 16 if you want to get 4 pounds. Most systems have most systems have 15-foot of line set built in, right? So if you just want to figure it out and not even convert to ounces, right? You don't even want to convert it to ounces. You just need to know how many pounds of refrigerant you need. If you got a residential system with 45 feet of line set, subtract the 15 that's already included in the condenser, then multiply that by your 0.04 and you'll get 1.2 pounds. Done. Charge is done. Um, so that's how I charge. I always weigh it in. So again, there's your snapshot on how many ounces or how many pounds per foot you need um, for any particular line set size. Always double check your manufacturer's instructions, but like I said, that's pretty constant. And my rule has always been as long as you calculate that to within plus or minus 10%. So, if you're not sure how long the line set is and it's about 50 foot and you're pretty sure it's no less than 45 and no more than 55 feet, you're probably fine. You don't have to get down to a single foot of measurement. As long as you get pretty darn close on calculating how long the line is, you should be fine. Um, do we want to get into evacuation yet? No, we don't. All right. So we covered pressure testing. We have covered flare joints, purging while you're brazing, temperature differences while pressure testing, um, additional charge for line set. And I think besides that, all we really have is vacuum. That is specific to VRF commissioning. Yeah. So before we get into vacuum, one more thing. POE versus PVE. So you're basically going to run into two types of oil when it comes into R410A systems. And most refrigerants now in general, right? When you're talking HFCs, it's going to be some PVE or POE oil. There's other options out there, but these are our two most common right now. Side note, in case you didn't know, some people don't know this, R22 can work with POE oil. Not too bad. If you've got a system you're converting from um, R22 to R407C, I know it's not done that much out there, but if you add 10% POE oil to the mineral oil that's in the system, in general, that system will work pretty fine without a full oil change. That's a whole nother topic, but just a quick tip. If you don't know what I'm talking about, look into it. But besides that, when we're talking new systems, we're talking VRF or 410A systems in general. Most of what you're going to run into is POE, which is what most people know about at this point, and PVE. And to be honest, I don't know why we use POE. POE is an absolute nightmare. PVE is kind of the way to go. And you know what? There was another slide I wanted to bring up on this. So where did it go? Okay. Let me save this. I'll put this in Google Classroom. Let me save this and open it up. Sorry. There we go. All right, so PVE versus POE oil. POE oil is a nightmare. PVE oil isn't much more fun. Mineral oil was it. So R22 and PVE will not work. R22 and POE will work, if I recall. Don't quote me on it, but I feel like we did a compressor replacement one time that was an R22 replacement, and I believe it was POE oil in the compressor, and we found out that POE and R22 will actually work. It just doesn't work that well mixed with mineral oil. But that's a complete aside anyway. We want to talk POE versus PVE. So 410A won't work in mineral oil. 410A will work with PVE or POE. American manufacturers tend to use POE, and that is true. All right. The difference between POE and PVE. With POE, when an alcohol and an organic acid react, an organic ester and water are produced. This is called esterification. This reaction is reversible. The reverse reaction of the ester and water to produce alcohol and the organic fatty acid is called hydrolysis. Okay? Um, Hydrolysis, we're going to get into that. Are we? All right, so hydrolysis is basically the breakdown of the oil, okay? See, hydrolysis, a big inconvenience, right? Hydrolysis is basically the breakdown of the oil. That's how I want you to remember it, all right? POE, you have to keep the containers closed. POE is extremely hygroscopic, which means it likes water. It wants a water molecule in it. So as soon as it sees water molecules, it holds it in, right? But in that water rapidly causes POE to turn into sludge. It rapidly damages the oil. All right. Dryers remove moisture from mineral oil and PVE. So if you stick your filter line dryer in, that dryer will remove the moisture. Dryers do not do a good job of removing moisture from POE once it's in there. So, all those R410A residential systems, once that moisture's in there, it's in there. Once it hits that POE oil, it's really not going anywhere. The dryer is not going to save your butt. So if you didn't do a good evacuation, it's in there. All right. It's an acid. It's there to stay. It's not going to be good. You have to minimize the time the systems are open. As a matter of fact, one of the funniest systems to me I worked on was a Liebert, I think it was. Yeah, it was a Liebert system, and it came in like two pieces. The refrigerant system came in two pieces, pre-charged with nitrogen or something, where you had to braze the condenser section to the evaporator section. It was basically like a modular package unit, and the instructions basically said you got like 3 minutes. You got 3 minutes to cut the line, connect it, and braze it up, okay? Don't take all day. You got 3 minutes. Once you open it up, don't let the moisture get in there. You got a few minutes to get it done, and that's it. And that's basically what you're doing. As soon as you open up a POE system, you are working against the clock. You are fighting the clock to get all that put together as quickly as possible so that it picks up as little moisture from the air as possible. In general, if I'm opening up the compressor oil to the atmosphere, then I'm keeping that thing purged as soon as it gets open. So, if I got to cut a condenser out and put it back, I'm going to, and I have to remove the refrigerant, right? I have to open the condenser for repair. Then what I will generally do is hook up my nitrogen to both sides, and as soon as I'm done evacuating recovering the refrigerant, as soon as I'm done doing that, I keep nitrogen hooked up and I keep constant flow through it so that the air never gets into the system. And then if I need to close it off, then I'll keep nitrogen flowing and then cap it off somehow so that the air never gets in contact with the system. But if you have to leave it open to atmosphere in general for whatever reason, then you've got a small amount of time to get that done. You need to get it done and then get some nitrogen or something back on it so that it's not being exposed to the atmosphere. So it's extremely important with POE. All right. Hydrolysis, that hydrolysis on the POE system is going to clog capillary tubes and create acid that destroys the motor windings. Okay, that's the base. The point is that the POE oil reacts with moisture, creates an acid. attacks winding coatings, and destroys compressors and clogs cap tubes. All right, so you need to avoid it. So they did inside of cap tubes. Daikin did this look with a dryer. You see what the system looks like. Without a dryer, you see what the system looked like. I mean, it gets bad. All right. Most of your mini splits and VRF systems use PVE oil. Okay. PVE oil. Here's the thing about PVE oil. It there's no hydrolysis, right? It's better solubility with processed fluids, superior resistance to cap tube blockage, unsuppressed lubricants, whatever. This is marketing stuff. Optimum for a non-dryer system. They tend to not put dryers on your mini splits and VRFs. So that's better. The advantage of PVE versus POE is the PVE will attract moisture even faster. So the PVE that's in your mini splits and VRF systems will attract that moisture in the air even quicker than POE. So you have to pay attention and still not let the system be open too long, right? But here's the thing, with the PVE, you can actually get the moisture back out. That's the advantage. I don't care about all this other marketing stuff about the advantages of no hydrolysis and crap like that. What I care is if the system does get contaminated, I can get that moisture back out. With POE, you can't do that. So here's how I remember PVE versus POE. PVE is more hygroscopic than POE, which means it attracts water even worse than the POE that's in your residential systems, hands down. Just it absorbs that water very quickly. But PVE, you can get the moisture out. POE, you cannot. That's how I remember it. Okay, that's your most important thing. Moisture is bad for both of them. Period. Hydrolysis is worse with POE than PVE, but it really doesn't matter. Moisture is always bad in a system, period. You don't want any moisture in the oil. I don't care about whether there's hydrolysis or not. The big deal is if the moisture gets into POE, you're screwed. If the moisture gets into PVE, I've seen mini splits that got contaminated take 2 days to vacuum out. But you know what? They vacuumed out. We got them to hold under, 500 microns. Not POE. It's not going to happen. It's just not going to happen. So that's PVE versus POE. And that's important when understanding mini splits. Okay. We got that. So last topic is vacuum. Last topic is vacuum, and I want to talk about vacuum for a while. All right. What I am going to do, well, let's look at the commissioning guide real quick. Let's see if there's anything in the commissioning guide. Yeah. All right. So before we get into more specifics about vacuuming systems down, this is the best way. This is a nice step-by-step right here, the best way to vacuum down a system. All right. They recommend a minimum 2 CFM vacuum pump. Most vacuum pumps we're going to use is at least 2 CFM anyway. Don't worry too much about the CFM of a vacuum pump. That's not as important as its capabilities. You want at least a decent 2-stage vacuum pump if you're vacuuming down a system. That's it. Done. All right. Digital micron gauge. Pick a good micron gauge. I'm not going to start calling out manufacturers here, but find a brand that you like the way it works. There's some brands I like, some brands I don't like. I will say one of the brands I tend to like is Yellow Jacket. I don't think I've ever used the CPS one they have pictured here, but these are pretty common. I didn't like the older Supcos, but the newer Supco, I've got one of those now, and I kind of like that. That's pretty nice. So Yellow Jacket and the newer Supco are the ones I've liked the most so far. There's some really nice ones out there that I've never bothered to purchase, but if you go on the forums and things like that, you'll get some good recommendations on micron gauges. Pick a micron gauge you feel like you can trust. We'll talk about how micron gauges work soon, but Just make sure you have a micron gauge you trust its reading, because uh, if you can't trust the micron gauge, you're not going to use it. And if you don't use it, you're not doing what you need to do. Okay. So ensure your vacuum hoses are in good condition. Generally, what I do is I try to change my gaskets in my hoses every few times after I vacuum. Make sure your gaskets are in good shape. Look at the gaskets on the end of your hoses and make sure they're in good shape. Or use, guys get really fancy with how they vacuum systems, but make sure that everything's in good condition before you start a vacuum, because it'll save a lot of headache. Evacuate the system to about 4,000 microns and hold for 15 minutes. So make sure the system will go down to 4,000 microns. I usually go 2. 4,000 is a decent number, I guess, but I like 2,000. I like to get it down to 2,000 and make sure that it holds. Break the vacuum with nitrogen to a level of 2 to 3 psi. You don't even need to do 2 to 3 psi. One, don't put it under pressure. Don't take it up to like 50 psi. That's not the purpose. Here's what I do. Break the vacuum by adding nitrogen into your pressure gauge. Even just starts to wiggle. You get to 1, 2 psi, whatever. Then open up the other side of the hose so that the nitrogen has to travel around the whole system. Okay, so it has to go from one end of the system to the other, because usually when you're doing it, you're only working on like the evap side, right? So make sure it has to go through the high side or the low side, whichever you prefer, through the coil, through the metering device, then out the other side. You can feel the nitrogen purging through and literally just purge it out the other side. Then hook your vacuum pump back up to go down to like 1,500. Usually I end up going 1,000. Go down to like 1,000, 1,500 microns. Hold it for a little bit. 20 minutes, maybe not necessary, but 10, 15 minutes on both these is what I do. All right. If I'm in a hurry, at least 5 minutes. Just make sure it goes down and it looks like it's holding. Purge it again. Same way. Take dry nitrogen in it. Make sure you break the vacuum so that air is not going to get in, and then purge it through the whole system, and then hook your pump back up. Evacuate the system to lower than 500 microns. You don't want to hit 500. I mean, on a residential system, if you at least hit 500, that's fine. But you want to be lower than 500. Get the system to below 500 microns, then conduct a micron rise test. System should hold below 500 microns for an hour. All right. So the way this gets explained is don't vacuum it down to 100 microns and then let it rise to 500. Okay. If the microns are constantly rising, you still may have a very small leak or some moisture in there. You want the microns to start to hold. You want it to like stay at 485 and not go above 485. Eventually, it's going to go up, but for an hour, you should be able to hold and barely move but maybe a few microns for an hour. Now, here's this a little known fact about most micron gauges. Their accuracy is generally plus or minus 20%. Okay. The last spec sheets I looked at for micron gauges, if you're reading 500, it might be 600 and it might be 400. But 20% of that number, that's your range of error basically on a micron gauge. So in my mind, as long as I'm holding within that range of error for an hour, that's kind of how I treat it. As long as I'm staying within that that resolution of that, not the resolution, but that tolerance of that reading, then I'm generally okay. If I start going outside the tolerance of that reading after an hour, then I start to worry I might still have a leak if it's continually rising. But you want to get it below 500, hold below 500. Typically, what I do is try and get down to 200 or 300, hold below 500 for as long as possible. Ideally, an hour, but for as long as possible, I watch it hold, or until I'm confident it's not going to go up above 500. As soon as I'm confident it's not going to rise above that, you're good. And then hold the vacuum and then charge with the vacuum on it. Okay. I like to, once I've got the system down to a vacuum, I like to have a 4-gauge manifold or 4-valve manifold, and while I'm vacuuming, I like to vacuum out the hose that's going to I'm gonna charge refrigerant through. So I have the refrigerant can hooked up with the hose attached to it, the refrigerant valve off, and I will be vacuuming out that hose I'm gonna be using for charging at the same time. So that as soon as I'm ready to charge and that vacuum's on, I just open up the can and let the refrigerant in. Done. I know that no air got in the system. Okay. Usually, what I'll do is I'll make sure I'm holding vacuum and then I'll leave the vacuum pump running until everything's ready to go. Close the valve on the vacuum pump, open the valve on the refrigerant. That way, even if there's by some chance there's some leak I didn't catch, no moisture gets drawn into the system by the time I open up the refrigerant. It stays in the vacuum. Maybe that's crazy. Maybe it's a step too far. There's plenty of flaws in the reasoning there, but that's how I like to do it. So just take it for what it's worth. All right. And then this goes into accurate refrigerant charging is critical, yada yada yada. But yeah, that's a good way. That is very good step by step on properly evacuating. With that in mind, I will put up on the Google Classroom this article from ACHR News on vacuuming. That will be a good resource. You can read through that. I was going to read through it, but you know what? You guys can handle it. Read through this article. ACHR News has a good article on vacuuming a system. So read through that and a little bit of nylog sealant on all my vacuum connection points. I do that too. It makes a big difference on a deep vacuum. This is 100% true. So anyway, I want you to read this whole thing. Consider that homework. Read this ACHR News article on um, vacuuming, on evacuation. And then here's another big tip. You know, one of the best places to get information about something is from a test instrument and equipment and material and whatever manufacturers. Manufacturers know a ton, an absolute metric ton about the things that they make and sell. Okay. So you want to know how to do a proper vacuum? Look at people who make micron gauges or people who make vacuum pumps and read what they have to say about properly doing a vacuum. They're generally going to give you very good information. In my experience, manufacturers do a great job of putting out training literature on tons of stuff. So, if you're ever looking for information, start there. See if a manufacturer has a guide on their stuff. So with that in mind, another thing I'll throw up, but this is JB's Deep Vacuum or Principles and Application Guide or whatever it is. And we're going to flip through some of the stuff in here because there's some interesting points in here that I always like to do. All right, so deep vacuum method is the best way to make sure you're free of non-condensables and you don't have leak. Micron is a unit of measurement from a perfect vacuum that is expressed in linear increments. 1 inch is 25,000, 4,000, 25. They added a zero there. 1 inch is 25,400 microns. So 1 micron is 25,400ths of an inch. All right. So when discussing in microns, that refers to total absolute pressure as opposed to gauge pressure. Um, that's loading slow. All right. Our microns are more accurate unit of measurement. It's a more fine unit of measurement, really, not necessarily more. I guess it's more accurate, but I think of it as a fine measurement. Um, Starting from the same measuring point from each time, Borden tube type gauge cannot read fractions. Look up what a Borden tube gauge is if you've never done it, and learn what a Borden tube type gauge is. There's something to Google for you. All right. Vacuuming is important. Um, The larger the pump, the faster you can do the job is not true. Most people know that by now. I think that's a well dispelled myth. But pumping capacity is not important. You don't necessarily need that 7 or 10 CFM pump. Um, get a nice pump. Don't get a pump with a high CFM. Just get a nice pump. Bigger isn't always better. Service valves have 1/4 inch flare ports with only 3/16 orifices. So, they say use big hoses. Big hoses help. But I really think the most important thing is removing the valve core, not having the big hoses. So, um, even though Appian and those guys make these big vacuum hoses with the connection ports, I would say the first investment you should make for pulling a good vacuum is to buy a core removal tool and use it. That will help you the most, hands down, every time. They say don't vacuum through your manifold, or, use hoses that are made for a vacuum and this and that. And those are good tips. Don't get me wrong, they're great tips. But it's nowhere near as important as just removing that Schrader core. Because if you've never looked at how much room you have to pull through a Schrader core, you're crazy. There's no room to pull through a Schrader core, period. The Schrader, the port is small, man. So remove the Schrader core, and that will help you 10,000 times more than anything else anybody tells you to do to pull a good vacuum. Period. All right. Vacuum pump creates a void for which pressure flows. A vacuum pump cannot create a larger pressure difference with a smaller pump. It's just not going to happen. So more CFM is not going to equal faster evacuation unless you're dealing with bigger valves. I guess the other thing you can do is, instead of just using a bigger Schrader core, is make yourself a bigger connection somehow to tie onto. You stick a 3/8 port on the system for you to vacuum through, and it'll go a lot quicker, right? But unless you do that, you've only got that 1/4 inch connection to pull through with that 3/16 port. So a bigger pump usually isn't going to make a big difference. And um, uh, where does it say it? I may have skipped it. All right. The other thing to keep in mind is, instead of one bigger pump, here you go. Depending on the system size, the system line sizes of large tonnage systems, instead of using a bigger pump, it's better to use 2 smaller pumps. And I can attest to that. A great way to speed up your vacuum on a large system like a VRF system is to put 2 pumps on the system, or 3 pumps at the system, preferably at different ends of the system, and vacuum down like that. That will actually speed up your vacuum more than trying to get a bigger pump on it. All right. So instead of going out and buying the new big pump, ask if you can borrow your buddy's pump for the day while you vacuum down the system, and that'll speed it up way more. All right. Um, this talks about different types of pumps. We don't care about different types of pumps. You want a nice 2-stage vacuum pump. You can't go wrong in the modern era with a decent 2-stage pump. All right. The gas ballast should be on all pumps used in refrigeration. At the start of evacuation, water vapor is quickly removed. If the system is laden with moisture, the oil gets contaminated fast. So you open the gas ballast. All right, that little gas ballast on your vacuum pump. Open that thing up until you get below 5 to 10,000 microns is usually what I end up doing. Until you start at least getting a decent micron reading. But open up the gas ballast until you start hitting a vacuum. You get down to about 10,000 microns or so, then you can start closing your gas ballast. That's generally how I deal with the gas ballast. And most manufacturer's instructions, read the instructions that come with the vacuum pump. It'll tell you things like that. All right. You want a blank off valve for your vacuum pump. Pump should be able to produce a vacuum low micron range with the safety vacuum of at least safety factor of at least 25 microns. Basically, you want a pump that'll pump down to, most pumps that are decent pumps will advertise they can get down to 25 to 50 microns, 15 microns sometimes even. So that's what you want. And JB Platinums hit micron rating of 15. I've never seen them hit 25 or 15, but I have gotten them down to, lowest microns I ever got down to was 90. I got down below 100 once on a pretty big system using 2 pumps. So you should be able to get down pretty low. If you have never gotten down to at least sub 200 microns before, do it. You should see that as possible and see that, especially if you pull Schrader cores and stuff, it's not that hard to do. It's not that hard to get well below 500 microns. Just because you never do it and it feels like it takes forever because you generally have some poor practices on vacuuming, you should do it, get used to doing it, and do it all the time. Um, all right, how a micron gauge works. I always thought this was real interesting, and I actually learned a lot about it trying to figure out how would you make your own micron gauge. That's a whole different story, but a micron gauge is actually a temperature sensing device. All right, it's I want to say it's a thermistor. I could be wrong there, but it's a temperature sensor. It's not a pressure sensor. All right. So a micron gauge is not a pressure sensor. Your pressure gauge cannot read in microns. All right. It is a heat sensor that basically senses the rate at which the heat is carried off. And that is what determines the micron rating. So it's basically detecting how much heat can be transferred. And the more heat that can be transferred, the more air there is to transfer the heat. Whereas if there's no air left in the system, if there's no atmosphere left in the system, then the heat can't move as well. So a micron gauge is basically a temperature gauge, not a pressure gauge. Just an interesting fact to keep in mind how it works. Um, it's either a thermocouple or a thermistor. I think most of the ones are really fine thermistors these days. They're very the sensors that go into vacuum gauges are extremely expensive. That's why good vacuum gauges are expensive. You know, you should have a micron gauge that has 50 to 40,000 or 20,000 microns. I think most of the ones I use are 50 to 20,000 microns. But anyway, you need a good micron gauge. Like I said, pick one you trust from a manufacturer you trust. Um, the, buy tools from manufacturers that if you call their support line, they're helpful. That's a good tip. Um, accuracy, vacuum sensors are not super accurate actually, but you want, like I said, one that doesn't jump around all the time. Um, what else? Evacuate through good gauge manifolds. Don't use cheap gauge manifolds, basically. O-ring sealed gauge manifolds are perfectly fine to pull a vacuum through. It's better to use a vacuum tree or something, or make your own vacuum tree. It's not that hard to make a vacuum tree, but for the most part, the main reason I like to pull through manifolds is it makes it more convenient to weigh my charge in as soon as the vacuum's done. Otherwise, you can weigh in a charge without your manifolds hooked up. That's fine too. You want to weigh in your charge anyway, so you don't need your gauges hooked up to pull a vacuum. Um, there's plenty of places for leaks to occur. Put some nylog on this fitting right here before you hook up your hose. You'll be surprised how big of a difference it makes on how quick that vacuum goes down. There's some notes about line size again. The line's ID is no larger than 3/16 that you're hooking up to. So any hose that's bigger on the inside than 3/16 isn't going to make too much of a difference. Short connecting lines are good. I'm looking for one more important point. Don't listen to anybody who says you can go on too deep of a vacuum. It's BS. I'm just going to leave it there. There's no damaging oil or anything like that, or vacuuming down too fast or any of that stuff. You want to go into a deep vacuum as quickly as possible. That's the end of it. The warmer the system is, the easier it is to vacuum. So if you can do anything to warm up the system before you start your vacuum, that will speed up your vacuum. But um, don't worry about vacuuming down too fast or going to too deep a vacuum. That's all basically myths. All right. Rapid rise in pressure indicates a leak. A slower rise to about 1,500 microns indicates moisture, and under 500 microns generally means you're good. Okay. I would say under 300, hold below 500 means you're good, especially on big VRF systems and stuff. That's what you want to do. But this is a really good reference. Anytime you have a rapid rise to any at all, anytime you got a fast rise in micron reading, you got a leak. If it rises up kind of slowly and starts to peak around 1,500 or 2,000, really I'd say 2,000. If you can't get it, if it'll get up to 2,000 and hold, but it'll keep rising up to 2,000, you still have moisture, just keep going. All right. There have been instances where I still had a leak and it was just rising slower as it went up. But in general, if I just hit 2,000, then it's just it's just moisture in the system still. If it feels like your vacuum is just taking forever, you probably have a leak, dude. I mean, that's just the way it is. If it does not hit 500 microns in a reasonable amount of time based on system size, so if we're talking mostly residential, we're talking max 30 to 45 minutes. You didn't pull the Schrader cords, 30 to 45 minutes. It's still under vacuum and you're not getting close to 500 microns, and you probably have a leak. One more go over because I saw it in this and it was a good point. It's something I've tried a lot and you realize it doesn't actually work. So where's the blank off test? Blank off test. Blank off test. There you go. All right, before you start, it's always a good idea to attach a micron gauge to the vacuum pump to make sure it pulls down to at least 50 microns. I'd say 100, maybe 200. As long as it gets down to at least 100 to 200 microns, you're probably okay. 50 is ideal. In the real world, if you hook up your micron gauge and you get down to 100 to 200 microns, you're probably fine. If you can't get below 300, you might have a leak in your rig or you might have contaminated oil. All right. You don't have to get down to 50, but I would say hook up the micron gauge to the pump. Make sure you get down to below 100 to 200 in a reasonably quick amount of time. It should not take very long at all, a couple minutes. All right. If it doesn't, your pump oil is contaminated. It should be changed. Period. Full stop. Start there and look at your O-ring condition. Do not shut off the blank off valve on a pump and expect the gauge to hold a vacuum, as the gauge will fall back to atmosphere. The sensor in the gauge is too close to the pump and does not have time to equalize. There is nothing you're going to be able to do to make that temperature sensor you have hooked up hold 50 microns in it with just it hooked up to the pump. That's why that never works. That doesn't mean there's something wrong with your gauge. You cannot, when you've got a very short hose and the micron gauge hooked up and you try to blank it off, it's generally not going to hold very well. It will rise. And that's because it's not made to hold a vacuum under the condition. All right. So, all right, I'll put these two up on the Google Classroom. You should read these. Learn some good evacuation practices. Use good practices while you're purging and you're brazing. Treat every system like it's a VRF system, and every system you put in should work perfectly fine with no problems. Do a good install and you'll be good to go. Got any questions? Let me know. Otherwise, that's what I had for this class.